Okay, cool. So yeah, so my name is Chris. I'm not a doctor. I'm a PhD student. So hopefully in 3 years. But I'm in the field right now too, doing stuff. So the internet connection is a bit spotty. Like, please don't hesitate to like ask me to repeat anything. That's totally fine. And just like let me know in chat. Everything is great. Let me just see if we can move this over. Yep. Okay, so hopefully y'all have had a chance to kind of do the start here thing, where you make an account on GitHub, download and install Git, and then download and install the GitHub desktop. Essentially what GitHub is it's like an online repository and sharing system, but it uses Git, which is kind of its own thing. So it's kind of like a must-have in order to run the desktop. And then there's like just some little info here on the cheat sheet about how to kind of do some of this like kind of fancier README stuff, which is really helpful, especially when you're sharing repositories, either with collaborators or advisors. And I can kind of do a quick introduction while I'm kind of like talking, just giving a base kind of primer on what GitHub is and why I think it's really useful, especially if you're starting or in the early stages of projects. But GitHub repositories are essentially just homes for all of like the files for your research project. But more importantly, like it stores all of the revision history for each file. And if you're doing any kind of coding, this is pretty invaluable because it'll show you like what your previous entry was and then kind of any changes. And so I can give you kind of just like a bit of a tour of like some of the ones that I use. So let's see. I think this is the one that I use a lot for the projects I'm doing. And I guess, yeah, just for the intro, I work with salamanders. I work with taurian salamanders in the family Rhycotritonidae. There's only 4 species. And so I'm doing different projects from eDNA to genomics. And so a lot of coding. So this is kind of where it's helpful. So this is the kind of main GitHub repository I use for my project. And so you can see like I have it set to private, though it is shared with 2 of my collaborators so they can look and kind of comment and add stuff. And I have these kind of different folders where everything lives. This is kind of following just kind of general practices for organizing data. There's like a folder for the code, for the raw data, and then figures. This little JDizzle thing is just like we observed like only the second ever observation of eggs for the species. So I just had a little folder for all of the files for a natural history note we submitted. And then kind of more manuscript stuff like coding in LaTeX, kind of pubs, which is just where I keep a lot of the sources that I use when I need to go back and reference things and results and tables. But I can kind of jump into code and show you kind of some of the practicality real quick. So the wonders of Fieldstation internet. So I have, kind of, I do most of my stuff either in R or Unix. So I can kind of like then pump it into Unix. And you'll notice with each folder, you see kind of the last commit message. So this just shows you every time that you are going to like upload changes to the stuff that you're working in, you're going to write a little blurb. And so that blurb is going to show. And so like for the RaxML, I haven't worked on that in 2 months, but because I'm in the field, but essentially RaxML is like tree building. So I can just see that like I updated that script. Then I can kind of click on that commit message and it'll kind of pull this up. So this is what I was talking about where it shares this kind of revision history. So the red would be stuff that I changed. So, and I was writing my code for kind of running stuff through RaxML and I got this error. So I ended up kind of doing different things to see what fixed it and ended up removing it because it was running. So stuff like that is really helpful in case you get error codes and stuff like that. And you can, see a working history of like all of the code that you used for your stuff. So it's pretty helpful. And again, like if, going back to that just like little earlier tip about kind of the RMD stuff. So this is kind of some of the nicer stuff you can do. So someone can kind of jump in and take a look at what you're doing. And I've included like a GIS map as well as some of the outputs of RackSML. And so just right away when someone sees it, it makes it very clear what each folder is for. But that's kind of enough of like, I guess, the intro methods, kind of like background stuff. And I think let's get into it just so we can kind of get a feel for how to use it. So if you haven't done the GitHub stuff, like please tell me. I'm just gonna like assume that you did. So we'll go into like the make repo section. And it's very helpful if you have the link to follow along. But just in case you don't, I'll kind of share that in chat just to be sure. So here's that. So again, in the main, and you can see here on the left, it shows me all of the different things that I'm in. So we kind of went past that intro and we can just jump into the make repo section. So again, like repositories are just kind of like these homes. You can think of them as like drives almost, like a shared workspace. So you'll just go ahead and we'll make kind of like our first one together. And I'll just go into GitHub. So you should be able to just like log in when you go into your GitHub, and it'll kind of give you this you know, kind of background. It should have your username in the top left, as well as the repositories that either you made or that someone else made for you. Let's see, we want service line. And it also shows you all your contributions, which is a great way to keep track of how much you're working / not working. So it's a little stressful. But in order to kind of make a new one, we'll click on that repositories in the top left. And again, if you're following along, kind of has screenshots to show. We're going to hit new, so that kind of big green button. And this is kind of just a blank thing of like what repository you want to make. In terms of template, this is something that, you know, usually I do no template. There are kind of some, again, more advanced things where like this is a manuscript template. So someone's actually kind of developed this GitHub template that's made so that as you're making this, it's essentially writing a manuscript for you. I have not had a chance to play with that yet. It sounds very fun, but also very time intensive. So you'll see here kind of in the owner, so that should be your username, and then repository name. So go ahead and kind of make something up. So for me, just kind of do SCB. And then you can kind of do a little description. So, you know, this is very fun. You can kind of leave it, you know, if you're doing your own personal data, it's kind of good to leave it private. I think, but you can also do public as well. And then you kind of always want to add this README file. And again, that README file is that section that kind of describes at each step, like essentially what's going on. This git ignore is something that won't be covering a lot, but there are file limits. I believe it's like 100 megabytes or so, but if you have a student account, it's higher. And so what you can do is kind of add these templates so that, you know, say you work with GIS data or a lot of big raster data, you can just add this kind of template that makes it so that anytime there's any kind of raster data that's over a set file limit, it won't try to upload it, which is very nice. And then again, for a license, that's not something that I've personally had to deal with. So we'll just hit that create repository. And so now you'll see that like we're kind of in this new repository that I've made. And I'll just come this over here, which again has that readme.md file. And I don't know if some of y'all are familiar with kind of Markdown. That's what MD stands for. A lot of people use it in R. But again, it's just kind of another programming language. So you can kind of go in and do stuff, you know, down the pipe to kind of change the font or insert like images and stuff. But it's kind of this initial commit that you have set. So now that you have this kind of set, this here, it's all pretty much set. So the first kind of step, I guess, is to add a folder. The way you add folders isn't very, como se dice, like explanatory or easy. So you would go to hit a create new file. So in this kind of, in your main repo, which you should be in your main repo now, just go to add file and hit create new file. And then you're going to type in the name of the new folder. This internet is fantastic. I'm so spoiled. I'm so used to my like Comcast Xfinity. I'm like, oh my God, I had to wait 5 seconds. Okay. And you're going to name your folder. So like, say in this case, we're just going to do like code. But instead of hitting enter, because that'll just create a file, you hit so that backslash, and then that creates the folder. And then you type in like readme.md. And then you would do like, you know, this is a folder where code lives. And then like hit that commit changes. And then, so you'll see right away that commit message. So that's going to be like the first thing that anyone sees, like kind of that last message about what you did. And I find it useful to write these extended descriptions for everyone, just so then kind of, you know, you're clear about what it is. At least for me personally, like when I'm doing a lot of coding, a lot of times I think that like that's all the coding I'm going to be doing, but it turns out I'm going to need to make edits later. So just try to be somewhat specific, but succinct, I guess. So just be like, you know, I created a folder for code, and then commit changes. And so now you'll kind of see it right here, like the name of the repository, and then the name of the folder you're in, and then it'll have the file within the folder. So click back on the name of the folder that you made to whatever the folder is, and you should see like now you have this folder called code. So within your repository, you like now have this folder code, and then if you click on that folder, you'll see that you have this README file. And then again, this is just like displayed here. So the first time you enter this, or anytime you enter this folder, you'll see this README file. So README file is just a great way to kind of keep track of what you're doing. And not sure if your browser will also have it, but you also have it on the left, where you should be able to kind of click this and it should have the folders that you have as well. So that's pretty much it for how you add folders and files. So again, it seems pretty straightforward, but it can be a little bit time intensive to like create all of these folders, you know, individually going through. And a lot of the times, you know, you're going to be working on your desktop or on your laptop, and you're going to be kind of working on this parent folder, and you want to be able to, you know, make these changes without logging onto the browser. And so that kind of will jump into kind of that next part of the thing. So on that like tutorial one, jump into that, you know, from that make to pull into that like kind of push pull, and then we can kind of go into the next section. And for me, like this part is what makes GitHub amazing. Like, you know, on some of my projects, like I don't necessarily collaborate a ton. Like, you know, to be quite honest, my advisor doesn't really do genomics. And so like, this is like, I only let her know what I'm doing when it's like pretty much done. But I do have a desktop at home, and then I have a laptop that I use like right now in the field, and then I have a computer at my office. And so being able to use GitHub makes me like able to really just like go from one to the other and just work on the same thing or in the same project in a way that's like really streamlined. So hopefully you have this GitHub desktop, and I'll kind of pull that up. So here's mine. So on the top left, you'll see it'll tell you the current repository. If you're already using GitHub, you'll have one, but if not, you're going to want to click on that add, and then you're going to want to do like clone repository. So it should log in all of the ones that you have. So for me, it's SCB, but for you, it'll be whatever the name of the last one that you did. And then here, you'll see this kind of local path. And that is important because that's, you know, where on your physical computer, it's going to be cloning this repository. So for me, because I have kind of a couple different projects, or like this disperse NN is actually someone else's repo that I use to try to look at like dispersal distance using snips. I keep them all within just a folder called GitHub on my D drive, which makes it really easy for me to remember where all this stuff is. But you would just kind of hit choose and just find, the name of what you have. So for me, again, it would be D and then GitHub. So select that folder. Let me just double check. So then you're going to clone that. And what that is essentially going to do is it's going to take that folder that you just created, as well as like everything within the repository. So the folder and then the README files, and it's going to clone it into your computer. And this kind of current repository just tells you like whatever repository you're working off of. So it's refreshing it. Sometimes it takes a little bit, but not too long with this kind of data. Yes, thank you. It's still refreshing it. And let's see if it looks like it's done. So now I should be able to go into that kind of D GitHub and then SCB, which I created. And so now you'll see like, that cold folder that we just made online is now on my personal, like, this is my laptop, as well as the README file. And what's kind of cool is in here, you can see, I usually use Visual Studio Basic, but again, it just is the README file and you can open it with Notepad, and you can kind of go into each folder and play with it. And so again, like, I feel like most of the work that we do is on our personal computers. So, say we want to like, add some data in there. So we can hit like go to like new and create a new folder and just type the data. And we want to upload, say, a Word file. I'm going to make a new one, but new Microsoft Word document. And data for a CV. So, and then probably edit it to say hello, just so it's not empty, I suppose. But you can do this with anything. It doesn't have to be a Word document, but just kind of put something in there, and then save it so that there's like an empty, or let's use it like a file in there. So that's closed. See, now it's kind of this 12 kilobyte. So I'll kind of close out of that. And then now I'll hit this. Well, I don't have to hit fetch, but it's already kind of pulled up like something has changed when I open up GitHub desktop. And it's like, now there's this folder as well as this data for scb.docx file. So this is kind of like the crux of using GitHub for desktop, is that your changes aren't uploaded automatically. They're uploaded when you push or pull. So push being like send to your repo, and then pull being like downloading from your repo. So in this kind of bottom left box, there's that main commit like message. So I'll be like, uploaded for.scv data. And then the description, say, like added docx file to data folder, added data folder, or something like that. And you hit that commit to main. And just what that's going to do is kind of, your computer is going to recognize now that there's this commit that you have here that still hasn't been pushed to GitHub. And so you'll hit this push origin button. And it'll kind of like, it always fetches the immediate one and then pushes to the cloud. So great. And then I can just hit fetch and it shouldn't do anything because it's already there. Let's see. Yeah, it's good. So now I can go, I don't need to do that. So now I'll go back into kind of this, oh my God, I thought that was my GitHub desktop. There was a screenshot. So now I'll go into my SCB code file, which again is the one that I just made. Click on SCB, and now you'll see here's this data folder, which I created on my computer, but just pushed to GitHub desktop. You can see that kind of commit message that I did, where I uploaded for SCB data. And then when I go into that folder, that docx file is there. So this is like a really kind of easy way to do it. But often, like if I'm doing a new GitHub repository for a project, to kind of save time, what I'll do is just make a ton of the folders and the readmes on my own personal computer, and then just like upload it all at once rather than going through the browser and doing that kind of /name /readme. But it's really up to you to kind of do whatever you think is most useful in the moment for you. So that's pretty much like just the core of how it works, is just that you do things on your own personal computer and you can kind of push. And so, you can see like why this would be really useful, because if you get a new laptop, you just download GitHub Desktop and you can pull everything that you've been working, and all of the file structure and everything goes in there automatically, which is really, really nice. Cool. So if you have any questions, let me know, but we can kind of jump into the next section, which will take a little bit more time. And this is kind of more about how you integrate this with compartmentalized coding, which I'm not sure if that's like the official term, but that's the way it was used for me. And so in order to do this, what we'll do is have you fork this repo on your computer. And forking means you're going to create a copy of it. So for this one, I'll kind of just walk through the screen share instead of like doing it on my own personal computer, because I like have this repo already. So again, what you're going to want to do here is go into the main page. So in this case, what you should be seeing is that kind of main page where it has like my username and the woofkers, and then kind of all of the things. And there's the fork option. And so I can't fork it because I own it. But what you're going to do is kind of hit that fork button. And then when you hit that fork button, what it'll do is show you kind of your name and then the name of woofkers. And actually, I guess what I could do is just, yeah, just do that. So let me know. Well, no, I'm just like talking a little longer, so I assume that you're in there. But yeah, just make sure you're on the GitHub website on kind of this main thing. Hit the fork button, and then when you hit that option, it'll have your name here instead of mine, and then as well as a repository name. And then just copy the main branch only and hit create fork. And what that's going to do is just create a copy of this repository onto your own personal GitHub account. So now you should see your name and then the name of the Rathway Woofkers kind of 2023. If you're having problems with that, let me know, but you should be able to now just see all of this as if it was yours, because you do have a copy of it now kind of in your own thing. And so what then you would then do is open up GitHub Desktop, and then this is where mine was set to SCB, so you're going to switch it to like the different one. So I can kind of show you again. An example is you would just like add existing, and say I have some that I cloned. Let's see, or actually, I'm sorry. Yeah, clone repository, and then I have ones like disperse NN. You can also just type in the whole URL for the repository as well, if you can't find that. Oh no. Okay. And then you just do everything the same way that we did for the previous instructions in terms of like just pulling it to your existing computer. And what it'll do is kind of create that, instead of having this kind of lock symbol or the open symbol, which just means private and public, you should have this kind of like little fork icon and then the name of this Rathway.Woofkers. And so it'll ask you how you're planning to use it. And it'll say, do you want to contribute to the project or for your own purposes? Contributing again is like, say you're working with your lab mates thing and you're going to be editing some of their code and kind of pushing it back. That's more of like the contribution, or if it's for your own purposes, like you're just going to be using it. So again, like just for instance, and I'm going to be using a lot of their code. So I'm just going to use that. And the only time I would kind of add anything to that is if I had some kind of issue, I might put it in the issue section or something. So assuming you've done that, you should be able to like open up File Explorer, and wherever you had it, you should now see all of the folders and kind of all of the files associated. And again, this example is just dispersing them, but for you, it should be kind of the same as this one, which I will do. So for me, it's not existing, but I'll choose that Raphael Wolfgers thing. Just do it all the same. Oops. Do clone, GitHub, Wolfgers, and clone. So I'm cloning into it. And the reason I'm like re-cloning it into it too, because I don't want any of the stuff in the last one to get in there. And it should be pretty fast because it's not a very big repository. It's just some very basic code. So now you should be able to kind of just pop into that D, wherever yours is, the GitHub, and now you should be able to just see all of this stuff in here. And that's just, you know, again, like you just clone that first into your GitHub account and then second onto your personal computer. So yeah, so then we can kind of then move into that R coding section, which again, I think is very, very cool. So go ahead and like open the folder on your personal computer, not in GitHub, for that kind of R coding and fork section. And then I think, and then also it is handy to kind of have that, this part as well. And you're going to kind of run them in different order. So like, first, we'll go into the R simulate. And if you don't have this on your computer and you're having some issue, again, let me know. But I've created all the folders in there for everything to live. So kind of open up R simulate.rmd. Yes, it's with RStudio. And so personally, like the way I've used R code in the past before I've kind of used this GitHub is that I had one massive R script for everything. So like I would have the, you know, in the R script, it would like clean the data. It would take the data and make it the appropriate format for, you know, whatever like package I was using. And then it would run the analysis, and then it would take that analysis and run it into models, and then it would do the plots on one huge script. But kind of one of the issues was that is just, for one, it's a huge file. But for two, if you want to like say, go back and make some changes to something, you have to run the whole thing from the beginning until that kind of point in your script where you want to change something. And oftentimes that can be like really time intensive, especially if you're on a field computer with field internet. So what you want to do in order to kind of save yourself some time is compartmentalize. And what that means is you're, instead of kind of creating like one R script that does everything, you have multiple R scripts that do different components. So this is again just kind of an RMD file, which is like really nice way to run through stuff because it's very plug and play. But this first chunk, again, that R simulate file just kind of sets a seed. And that's whenever you're kind of simulating data, setting a seed, make sure that those results are reproducible if someone uses that same seed to generate. So we'll just generate some data at first. So this data set, we'll say it's like we're creating, I don't know, a set of DBH measurements. So just create a data set where it's going to pull 16 values from a normal distribution, a mean of 6 and a standard deviation of 2. And then say we're doing, you know, something in the forest about how big the trees are. But then like we have this kind of like count for salamanders in each tree. And we'll kind of simulate this data as if we had a count of salamanders again, with a mean of 20 and a standard deviation of 6. And so now you'll see kind of in your values thing, it'll be, these kind of values. So it's not like a lot of code, but like when I do like my eDNA stuff, or genomic stuff, it's a ton of code. So instead of kind of like having all of this data that we've pulled in here from our local computer and everything, what I'll do in this code chunk is set the working directory to wherever I've saved this folder, which actually in this case is not there because I did this workshop not on my laptop. And I can kind of show you that. It's actually kind of helpful because this is how you'll be able to like navigate between computers from one to the other. So you set this working directory to wherever you have your GitHub. So for me, like, this again, I said it's in GitHub and it's in this Rathway Woofgers. So this C drive /phd/git wouldn't work on this laptop. It needs to be this like D, then GitHub, then the rest. So I kind of just go in there and change it to this. And you should be doing this for wherever you saved yours. So for me, it's in this d.github, but wherever you saved on your local computer this folder to, you should be editing this line of code in order to match that physical location. So now kind of when I hit this like play thing, oh yeah, that's fine. I should be able to kind of open up this, Rathway Woofgers, kind of R coding and fork. And in this dataset creation, there's this Sally's on wood thing. And you can see from like the last day it was modified, that it was modified at 1:44 EM, which is now on 7/19. And this is kind of that crux of that is like, now whenever I kind of share this file with someone, in order for them to run it on their own computer, all they need to do is go straight to wherever the working drive is set, change it to their local computer, and then everything else is going to be the same. And the reason why is because it uses a relative path instead of an absolute path. And just to kind of clarify, I guess what that is like this right here is an absolute path. So the path that it's being set to find something on my computer is like the D drive, this folder, and this folder. But this uses like a dot and then a slash, which means it's a relative path. So this is just wherever the working drive is, it's going to go into that working drive, move one folder down, find this folder, go one folder down, and kind of do that. So that's kind of how it works. So now, instead of having to do this simulation every time, I now have this R data file. And the way that this works is it's saving this DBH as well as this Sally to this Sally on wood R data. And R data just compresses data sets into like its own kind of object, which you can then upload. So let me just double check. Everything's in there. And usually it's nice to kind of have that thing on your go-to, and instead of opening it and closing this, I'll just leave it open. So yeah, I can see it's there. That's kind of like our work spot. And I can kind of just go on that and click Control Enter and make sure that it works. Oh my God. Let me make sure that I named it right. GitHub. Oh, no, I didn't. And this is why checking is good. That is not capital, it's lowercase. Oh, let me double check. Well, let me know if it's working on your computer. First off, like, I guess if you're in this R thing, and then if it's if you're able to kind of set that, and one thing I can do too is double check by, often what I'll do is kind of like copy this path and then just open it in a new one and make sure that I typed it right. So it looks like D, GitHub, so yeah, I'm actually not sure why it's not working. Because it should be, but let me try this real quick to see if it's the case. Okay, so now I set the working drives there. And now it still does that. And now let me double check that this is there appropriately are coding for separation to our data. Oh, yeah, it's there already. Okay, never mind. That's why it was already there. So my bad. Yeah, that's weird. So anyways, I'll clear the environment because a lot of times I do get these errors when I don't clear the environment. And now it should be able to, no, I don't want to say this change this, to just kind of go into the next like section or whatever. So this would be like a nice test because the next section relies on that. So yeah, so that's kind of like the initial thing of where you simulate the data and then save it as its own thing, as our data file, which again is nice. And it compresses it to an order of magnitude because some of the models I have are like hundreds of megabytes, which are bigger than what you can save in GitHub. When you compress it, it compresses it generally down to like 9 megabytes or smaller, which is really nice because it allows you to shave some pretty complex models in an easier way. So now kind of pop back into GitHub and then open that second part of the R coding and fork, which I believe is the analysis. I'll just double check. Yeah, that R, so it's the R modeling. So open that up. And again, with that note, every time you do this, you have to kind of change that working directory file. So open that up in R modeling. Oh, I need to close Samba. Samba is killing R right now. So again, I'll kind of go into this and then change that working directory. For you, it'll be whatever you have, but for me, it's all in here. And hit that kind of play button. Great. Okay, it did work. I don't know why I was tripping so much. But probably just panic mode. So it loaded this R data file, and instead of having a data file, so now you'll see like, again, the deviation Sally data that we simulated is already like right in there. So that initial like RMD, that R code that we had, created this data, saved it as an R object, and then cleaned the working directory. So now, from now on, if I wanted to work with this data, I don't need to go back in there and like simulate it and create it again. I can just run this code, which now pulls that R data, puts it in the working directory, and keeps going. So like now we can do some modeling. So do kind of like a basic linear model where we're modeling like the abundance of salamanders as a function of DBH, but this can be anything, you know. So it creates this kind of this model here. And of course it's simple. And like I said, we can kind of save it. So you just kind of save it, saves it as our data file, run it and clear it, and just, oh, and then you can open the next script. And again, part of the reason, like this seems like kind of redundant, but the reason I kind of have it in here is just to show kind of how easy it is to kind of make these different files in order that you don't have to like do the same thing over and over again. So this is, again, really useful when you're sharing stuff with your advisor as well. So now you can see that environment's empty, and we'll kind of open that next one, which is that R analysis. And again, this is kind of redundant, but you always have to change it. Okay, and then it'll load both the data and then the model. So again, just hit play. When it's set the working directory, use these kind of relative paths to go into different folders and pull this data. So now the model that we made, that linear model, is there, as well as the original values. And it's ready to go. So you can kind of do some analysis, hit summary model, and it'll kind of give you, the data. So like in this case, the p-value is not very high. So there's probably not a correlation between these kind of DDH values and then Sally values. And the cool thing about the R Markdown is it kind of shows it in here, and then you can just hit this little arrow to like collapse that and then kind of keep moving. So, let's say like your PI doesn't believe you. So like you need to like get something for them so that you can show them what you've been doing. So you can kind of just make confidence intervals for this linear model, which just confident commands. Again, you don't really have to set the working drive again. So I'll probably just delete that. And then save it into this this file as like our data. Yeah, should be good. And then you should be able to also write a table using that same folder as well. And then when you open your folder, again, you can kind of go in here and look into like the simulated model, simulated analysis, and all that stuff is going to be in there. And you can tell, again, based on the timestamp of when it was done. So yeah, so you clear the environment, work it through, and it's pretty much it. Yeah, so I apologize. I bet a little bit for the hiccup. I very much panicked when the code wasn't working, but it was working. No, it's just being a bit trying to rerun things multiple times. That's pretty much it for like the R compartmentalized stuff, which again, is just one of the reasons I love this so much. Personally, like I find it difficult to say start working on a project and then go back to it. And using this has made it really easy for me. So I can kind of show you in, one of the eDNA projects that I've been working on. That's what I did in order to kind of just be able to jump back into my workshop or into my work. So the files are pretty big, but I can kind of pull this up. So in this kind of eDNA, I can jump into code. MSOC is it's a Bayesian like hierarchical model package for kind of assessing detection probabilities at different levels. The eDNA, you have like a detection at like the site sample and then PCR replicate level. And so you can kind of see these now when I jump back into it, I don't have to do any of the data frames again. I don't have to do any of the modeling again. Everything is already in there. So it makes it really easy. Yeah, I bet it is too slow for that because these are huge models and they take like a bit of time to run. But now I don't have to run them. I can just open our data files and go back into it. So that's pretty much the main thing. There's a lot more you can do, but this just wanted to give you like really like the bare bones intro of what it's like to like make a repository, work with it. And then finally, kind of that most important thing is like hitting that fetch origin thing on whatever you did. And, you'll see that like things have changed. So like those are data files and you need to push it. And that's something that I would just say is really important to get in the habit of doing is whenever you kind of make changes to any kind of your files, like whether it be codes or data or results, just get in the habit of going into your GitHub, hitting that push and pushing it to the thing. Because if you don't do that, then you're not backing it up. There are ways to do that. Like in RStudio, you can have a little GitHub thing. And like for code, I use Visual Studio Code, but there's a ton of other kind of software. And most of those also have GitHub extensions that are built in that you can then just open your code and you can just hit commit directly from the software. But some people kind of like the ritual of just going into GitHub desktop and doing it from there. It feels like just very complete in what they're doing. One other thing that you can do is create alternate branches. This is something that I should actually get a lot better at doing, because what you can do is within your GitHub, you just create these other branches. So like, I'm using MSOC for most of my analysis for eDNA, but what if I decide I want to use eDNA occupancy or like a different kind of model? Instead of like rewriting everything that I just did, you can create kind of this like alternate timeline where you make a new branch, do everything again, and then whatever pieces you decide to keep, you can kind of coalesce back into your initial main branch, but you don't have to. And then I also have like a desktop app, a mobile app, which I find very useful if I'm like, I don't know how it is at your university, but we have a lot of advisors that pretty much only want to meet at happy hour. And it's really nice to be able to like pull stuff up on my phone and be like, so this is like the PCA plot I'm working with. Like, this is like the structure plot. Like, what do you think? And then get feedback in a more like kind of chill environment. So yeah, so that's pretty much it. Definitely, if you have any questions, like, please let me know. And then you can always email me too, but yeah, hopefully that was helpful.
Thank you so much, Chris. Are there any questions from folks in the audience? If you want to type those down, or if you want to unmute yourselves and just ask. We have a few minutes left for today.
Chris, I was just going to say, maybe if you want to drop your email in the chat in case anybody needs to reach out to you.
Yeah, no problem.
Yeah, and I was also going to mention that the recording for this workshop will be available just before our next workshop. So you can expect it, within, I would say, 24 to 48 hours before the next workshop, in case you want to review it again or review it in the future. It'll be made public through our YouTube site.
And then the GitHub is always public, and I feel like it's pretty easy to follow with the screenshots and stuff. So feel free to like even share it with people if you did find it helpful or whatever, or just go back to it whenever you need.
Any final questions? Seems like everyone's really happy with the workshop.
Yeah, I'm glad it was helpful. I'm glad my internet didn't die. It was good.
Especially that.
Yeah.
Yeah, thank you very much, Chris. This was really great. Good information.
Well, if there aren't any more questions, I guess this is a good time as any to end today's workshop. Chris, thank you once again for everything. But if anyone has any questions about today's workshop or our future workshops, or just anything SCBNA related, you can contact me or contact Anna. I'll actually drop in the email for our organization. And we'll be happy to answer any questions you have about future workshops, future opportunities, including our conference in 2024. Okay. Well, thanks everyone for attending, and I wish you all a great day.
Thanks, Joe. Take care.
And thanks, Bernie.
No worries. Thanks, Anna.